In these problems, we're going to attempt to define or determine the symmetry of some different functions based on whether they're what we call odd or even functions. And functions have some really interesting properties. One of them is oddness and evenness. It's not exactly like odd and even numbers, although it has something in common with it. Let me give you an example of an even function. So here is y equals x squared. You notice that the power of x here is even. That's a little clue, something that might ring a bell for you as we do these. And you'll notice that this function has symmetry about the y-axis. So if you reflect this over the y-axis, you get the same thing. So this is what we call an even function. Another even function would be y equals x to the fourth, which looks similar to this, except it's a little bit flatter to begin with and goes out. It's more like a U shape. Same kind of symmetry. So all even functions have this symmetry about the y-axis. Another one would be y equals the cosine of x. And the cosine looks like that. And you can see if you flip it across, it's going to be symmetrical. So those are even functions. Odd functions, let's see, y equals x cubed, an odd number up there on the power, that's a clue, is going to look like this. And the kind of symmetry this has is rotational symmetry about the origin. So if you spun this thing around 180 degrees, it would look the same. That's the kind of symmetry that odd functions have. Another example of an odd function would be y equals the sine of x. And I'll leave that to you to take a look at the graph and figure out how, in your own head, you could imagine rotating that 180 degrees about the origin. There are a couple of tests we're going to use to determine whether a function is odd. A function can be odd, it can be even, or it can be neither. Some functions, many functions, are neither. An even function has this property that the function equals the function of its negative x value. Okay? So f of x equals f of x equals f of negative x. So if you look back at y, or f of x equals x squared, if I put in a 2 for x, it equals 4. If I put in a negative 2 for x, it equals 4. So that satisfies this condition. For odd functions, it's a little bit different. Negative of the whole function equals the f of the negative x. So for example, on y equals x cubed, if I put in a negative 1, or if I put in a 1 for x, I would get 1 for y. So this would be 1, and then I'd put that negative sign on it. And if I put in a 1 here, then that would become a negative 1, and x negative 1 cubed is negative 1. So these are the tests we're going to apply to see if a function is odd or even. Let's look at a couple problems. This first one says determine the symmetry of this polynomial function negative 4x to the fifth plus x. And I'm seeing a fifth power and a first power. They're all odd powers. So the first thing that occurs to me is that this might be an odd function. So if it is an odd function, it's going to have symmetry about the origin. But let's test it. Remember, the test for the odd function is that the negative of the whole function equals f of negative x. So how do I write negative of the whole function? Well, I'm going to take this whole thing and put it in parentheses with a negative sign on the outside. And we'll simplify that later. And then, how do I take the function of negative x? Well, I'm just going to put in a negative x for x everywhere I see it. So I'll write the rest of the function as I normally would. Negative 4, instead of times x, it's times negative x to the fifth power, plus, and instead of x, a negative x. Okay, now we want to see if these things are really the same. So let me put distribute my negative sign here. So this becomes a positive 4x to the fifth minus x on this side. And on this side, well, what's negative x raised to the fifth power? It's just negative x. So this negative sign and this negative sign are going to cancel out. So this becomes 4x to the fifth. And plus a negative x, well, that's just minus x. And what do you know? Those are exactly the same. So this is odd, and it has symmetry about the origin. All right, let's try another one. So this one says identify the type of symmetry, if any of the graph of the function. So we've got g of x equals x to the third over x to the fifth plus 1. And I'm seeing a lot of these odd powers. So I'm thinking, okay, maybe it's an odd function. So let's go ahead and try that. We'll do the same thing we did. Negative f of x equals f of negative x. So negative f of x is going to be like this. And f of negative x is going to look like this. Negative x quantity cubed and negative x quantity to the fifth plus 1. Rest of the function written as normal. Now, how do I make this thing negative? Well, with a fraction, you know, if you want to make it negative, you just put the negative, apply the negative sign to the top or the bottom, not both. If you did it to both, they'd cancel out. So I'm going to take this negative sign and apply it to the top. So that's negative x to the third over x to the fifth plus 1. And here, negative x quantity cubed is just negative x cubed. Well, that looks like it matches so far. And down here, negative x to the fifth is negative x to the fifth plus 1. And what I see is that these are not the same. The denominators are not the same here, while the numerators are. So these two do not equal each other. So this is not an odd function. I guess I could test whether it's an even function. And remember, the test for an even function is that f of x equals f of negative x. So let's go ahead and try that. So x cubed over x to the fifth plus 1, that's just our regular function. And I guess I've already figured out f of negative x, right? That's this down here. So does that equal negative x to the third over negative x to the fifth plus 1? And it might be a little hard to tell. One thing you can do always is you can multiply everything by a negative 1 and see if it looks the same. In this case, you know, the top and the bottom by a negative 1. If I did that over here, I'd get negative x cubed over negative x to the fifth minus 1. And that's still not the same as this. So there's no way I can manipulate this to make it be the same as this. So it's not even either. So this function has no symmetry. All right, let's look at one more. Here we have a regular old polynomial. Determine the symmetry of this polynomial function. And I'm seeing x to the eighth, x to the fourth, x to the second. So they're all even powers. So I'm thinking this might be an even function. So let's do that test. And remember, the test for an even function is that f of x equals f of negative x. So let's do that. 5x to the eighth plus x to the fourth minus 2x squared minus 3 is going to equal 5 times negative x to the eighth plus negative x to the fourth minus 2 negative x squared minus 3. Now you may be able to see this already, but when you take a negative x and you raise it to an even power, which happens here, here, and here, it just becomes a positive x. So this becomes 5x to the eighth plus x to the fourth. That minus 2 doesn't get changed, it stays there. This becomes x to the second and minus 3. That's exactly what we have here. So this is an even function, and it is symmetric about the y-axis. So that's a little bit of work with odd and even functions and their symmetry. My name is Larry. I'm a teacher at EdVisions Off Campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.